Well, welcome back to the Azure Podcast. This is episode number 501, being recorded on the 31st of July, 2024, with special guests Arpita Chatterjee and Noah Wood. I'm Sajid, and on Teams with me, we have Cynthia. Good to see her again after a while, and special guests, Arpita and Noah, who we're going to get to in just a minute. But before that, let's cover some news in the Azure space. Cynthia, I put a few updates in there. I'll go ahead and cover them, and of course, feel free to jump in. Any of you, actually, if you have any comments on these updates. So the first one is related to the Azure disks, right, in VMs. I mean, typically, if you've got the slower SKUs like HDD or the V1 of the STD, and you want to migrate to the more later V2 of the STD, which is obviously the fast SSD, which is the fastest. There is a bit of a downtime you got to take. It has to copy everything over, and it's not a seamless process, right? They've now made it really easy to actually migrate up to the faster disks with very minimal downtime. It's kind of almost instantaneous. So, I guess if you feel you need to upgrade this is the chance to do it without having an elongated downtime on that. Also, if you use Azure Monitor, the Azure Monitor Basic Logs plan, which has been very popular because it's very cost effective. Azure Monitor uh, sometimes can be quite expensive because they have to store all your data. But the basic log plan has typically had only 8 days of retention. They've now increased that to 30 days. So, all the more reason to use that. And they've also provided full KQL access into the log. So now you can do all sorts of queries on it. It used to be there was a very limited set of KQL queries you could run on it. Now they've opened up the whole thing, and you can also do some analytics on the log. So certainly, if you're holding back on using Azure Monitor logs, the basic plan, I think, sounds like a good approach. Yeah, we've talked about app service environments in the past. These are special SKUs of the app services. Cynthia's smiling over here, and we've kind of discussed how at some point we're going to have to migrate the V1 and the V2 SKUs, and that time is coming soon, August 31st, 2024, which is just a month away from today, exactly a month actually. So if you're still on V1 or V2 of that, you should be up on V3 as soon as possible. So keep an eye on that. Then regarding Azure Functions, which I think most of the developers in Azure love to use it. If you use .NET, .NET 8 is now available for the in-process model in Azure Functions, so you can take advantage of the latest version of .NET there. And also in Azure Functions, Azure Functions has a nice way where you can get triggered, right? Like if there's a blob storage change or a database change or some new message in the queue, you can trigger a function. Now you can actually integrate it with Redis as well. So if there is a change in some Redis key or a table in Redis, that can also trigger your Azure Functions, which I think will open the door to some interesting functionality. And then, the AI is all the rage these days. And of course, our Azure database for PostgreSQL doesn't want to be left behind. So they have added vector database support now in that they call it PG Vector. And so it's if you're kind of interested in doing storing things like embeddings in your database in their native form, please take a look at that. And finally, the Custo database, which is kind of the backend database for all the logs are stored. In the past, you could query that it was optimized for append only, right? I mean, that's how we get the speed of Custo databases, because you typically just add records to them. Then customers said, hey, we wanted to have functionality to delete records. So they added delete. But there was never a way to update the records. And so now they've added a way where you can update the records. But the way the updates are done is actually deletes the record and adds a new one at the end. But so you can actually do updates now. So if there's for example, you had to go and change some tag or something on various entries in your Custo database, you can actually go and update them using this new feature. So those are kind of all the updates we had in the Azure space. Cynthia, anything else come top of mind to you? Okay, no worries. Yeah, and I mean, I'll kind of mention. I know, yesterday we'll probably try and cover this next week, but yesterday we did have like a rather nasty outage in Azure. We had a networking outage that impacted almost every customer around the world to various varying degrees. So we'll certainly talk about that, see if we can get some details from Evan next time. He's probably deep in the trenches on it right now, so I can see why he's not here. We'll see if we can provide some insights into what happened over there and give our listeners some details on that. But now's the time where we turn the mic over to our special guests, Arpita and Noah. Thanks so much for joining us. Please introduce yourselves. Tell us what you do at Microsoft, what your passion is, and what are you working on these days?
Yeah, hi everybody. I'm Arpita Chatterjee, Senior Product Manager in Azure Compute, with primary focus on Azure Cobalt-based VMs. Hi everybody.
Hey.
And hi, thanks for having us on. It's a pleasure to be here. My name is Noah Wood. I'm also a product manager in Azure Core, working on ARM VMs. I've been working on ARM VMs for 3 years now. I'm coming up, actually, it will be 3 years in 2 days of being in Azure Core, which is exciting times. And we're here today to talk about the Azure Cobalt 100 processor and the new VMs that it powers, which are in public preview right now.
That's really cool. Yeah, I remember when hearing about that. It's a cool name, by the way, Agile Cobalt. But give us some insights, into. And it's interesting to know that you've been working in this for almost 3 years now. But what were some of the driving factors from customers that you were seeing that said, hey, we need to build something like this, right? And we'll get into what it is that you built, but what was some of the driving factors to build something like a Cobalt, which I'm assuming is like an ARM processor that we have in Azure for workloads, but why ARM? Like what are customers asking that we had to do something like this?
Yeah, so I think it's maybe important to kind of rewind to 3 years ago when I joined, right? And we have been working on the Azure Cobalt 100 for a while now, since even before I joined Microsoft. But it's not powering the first ARM VMs that we've launched in Azure. The first ARM VMs were actually launched back in 2022. So 2 years prior, the ARM v5 VMs, or general purpose D series and E series v5 VMs. So the Cobalt 100 and the Cobalt 100 VMs, which are D series and E series v6 VMs, are kind of the second generation of ARM VMs, and they bring a number of improvements from the prior generation of ARM. And so why did we introduce ARM in Azure? We hear customers tell us that they need more price performance and they want a more sustainable solution to scale out their cloud scale web tier cloud native workloads, right? And so as ARM has kind of penetrated the data center space, if we look 20 years ago, 10 years ago, ARM servers weren't necessarily being looked at for the data center or hyperscale environment, but the performance has caught up, and ARM VMs and ARM servers are able to offer extremely competitive price performance comparable to traditional x86-based servers. And we're able to offer them at a lower cost because ARM servers use less power. That's kind of the bread and butter of ARM. It's a more power efficient processor archetype there. And so price performance is kind of the core requirement of a lot of our customers across a wide range of workloads. ARM specifically offers great benefits to cloud native workloads because it has a single physical core per vCPU, as compared to a traditional x86 based server, which will have two logical cores, or SMT, or hyper-threading, if you've heard any of those terms before. So with a full physical core, customers can expect more linear performance scaling as their workloads go up in thread count or process count, and they can also expect performance consistency at scale. So it's really the price performance benefits you can get from ARM. It's the sustainability benefits because the servers are using less power. And then it's the optimizations for cloud native workloads. And the Cobalt 100 is really doubling down on those benefits in all three areas. And we're offering significant improvements in local storage performance, Java, .NET, Redis, network bandwidth. It's really an improvement across the board from the prior generation, and we feel it's a great product for our customers.
Yeah, Arpita, go ahead.
Yeah, just to add to that, why Microsoft has taken a system level approach is basically as we were just discussing, right? Like better infrastructure in terms of price, performance, and power efficiency. First of all, second of all, basically we wanted to diversify our Azure infrastructure so that we give the choice to our customer whether you want to use x86 versus ARM, whatever best works for them. And third of all, obviously we wanted to customize our processor so that we can drive more innovation, customer innovations, and workload optimization and agile go-to-market approach per se. So pretty much, we want to have end-to-end so that, our customers are benefited at the end.
I guess I'm curious, how much, what sort of demand, like even in prior to Cobalt, how much percentage of our customers were using ARM? Is that something we can kind of publicly disclose? What was the demand like? I'm just curious versus Intel processors.
I think unfortunately that's not something we can disclose.
Okay.
That information is highly sensitive. We can give ranges. I'll say that thousands of customers were interested in ARM.
Significant amount of customers
Yes.
were using the Gen 1 ARM
Yes.
SKUs, and so that
Yes.
that's okay. All right. Yeah.
Yeah. In general, ARM ecosystem is developing, right? So more and more customers are transitioning from, x86 to ARM. In general, overall, the market is growing. So that is benefiting, obviously. So with the ARM ecosystem developing.
My question is kind of follow up to what you just mentioned. So if they were to go from one type of SKU to another, one type of series to another, how do you usually see that evolution going? And what are some tools or some playbook for them to follow to make that transition as smooth as possible?
That's a very good question, and one that our customers ask us every single day, right? I think we can kind of separate this into two types of transitions, right? There is your traditional, I'm running on a Intel DV3 and I want to move to an Intel DV5, right? That transition is fairly simple to do. It's just a matter of we expect our customers would validate their workload on the latest generation to ensure that their performance is as expected. They might have to change some of their workload scaling optimization points, right? So they'll do some validation. They'll make sure it looks good. And then they'd have to do some sort of scale down on the V3 and a scale up on the V5. Unfortunately, there is no service today to seamlessly just shift a customer's workload from an older VM to a new VM. But the transition is fairly seamless. The main I guess hurdle is going to be having to deal with the potentially brownouts or downtime that could occur when like switching one VM to another. Switching to ARM is a different story entirely because you can't just move your code from an x86 based server to an ARM based server and expect it to run. I mean, sometimes it will, right? If it's Java or .NET 8, maybe it just will run. But a lot of our customers have highly sophisticated workloads that are optimized even down to the processor architecture. And so it's going to require a more intensive investigation and validation in terms of, does the workload run on ARM, checking that, and then if it doesn't, fixing the parts or porting the parts that don't run on ARM to ARM. So this is not even necessarily a VM specific investigation or effort sizing there. But once they can port their workload to ARM, then it's going to be the same exact process of migrating from an older VM to a new one. You scale down and scale up at the same time. Arpita, did you have things to add there?
Yeah, just a quick couple of more things like, if I'm a customer, say, for example, I would like to decide on, these are a couple of things like I would like to decide on financial impact to me, like how are the VMs priced, first of all, and that helps, right? Because ARMs are obviously much more, priced better compared to x86. That would be the first thing. Then second of all, whether it is meeting my technical specs and requirements of my infrastructure. So in that way as well, I will need to see whether ARM VMs are actually, the spec wise, the performance wise, memory wise, the VMs and the CPU wise, are we meeting the specs? Second of all. Third of all, I would say more of a convenience, whether, ARM VMs are present in the regions where I want, whether the ARM VMs are available and look and feel the same as an x86, so that my engineering team has a less of a ramp time and learning curve, so that way is more convenient for my team. And obviously ARM is more eco-friendly, given the power benefits that we have. It's much more power efficient than x86. So these would be my deciding factor. Once as a customer I have decided that yes, now I want to go for ARM, now comes the story of porting the x86 into ARM, and then making sure we are optimizing the workloads, and then maintenance part is there.
That's great. Yeah, I was going to kind of add on to what Noah was saying in terms of the various workloads that could run in ARM. I'm guessing Python may be another option, right? Because these days a lot of people are doing Python, and that seems to work kind of across processors here. But speaking of Python, I was wondering the type of workloads that customers should keep in mind when deciding to go to ARM, right? And I'm guessing like, if we're doing like AI, deep AI stuff, maybe that is or isn't the right option. I don't know. So I'm looking at it from that perspective. What sort of workloads is it? Like, oh, I've got the run-of-the-mill web server. That's a great option. Or, I've got this, database server that may not be. I'm just kind of wondering what our general guidance is and like, what they should think about when moving to ARM. Obviously, if they're getting a lower price, they'll be that's an interesting option to have, but I'm guessing it doesn't work for all workloads.
Arpita, did you want to take this one? Oh, I think we lost Arpita. That's okay. So I'll take this one. We're refreshing and offering general purpose and memory optimized VMs with ARM, right? So the general purpose and memory optimized are really kind of the most broadly used virtual machines that are meant to support a wide range of workloads, right? For ARM specifically, what we recommend are cloud native web tier workloads. So that covers a wide range of workloads, understandably. We're seeing many customers run AKS, containerized workloads, open source databases. Databases run well on ARM. You could do that on an E series. You could do data analytics or a Spark stack on ARM. We see many customers do that. And I think instead of covering all the workloads, because really ARM can work for many scenarios, we should kind of look at what doesn't run well on ARM. You mentioned AI, and while you can run an AI workload on ARM, we generally wouldn't recommend doing training on ARM. We'd recommend training on one of our GPU optimized instances or GPU optimized families. You can run inference for small models, small to medium models on ARM, but you're going to get most likely better performance on an x86-based server. And then we also wouldn't recommend our customers to run high performance scenarios or ultra high performance scenarios where a traditional x86-based server is likely going to give them more performance. So containerized databases, web servers, app servers, broad range of workloads is going to run well on ARM.
And when it comes to the things like disk access from an ARM-based, like maybe the Cobalt-based servers, we've had some folks from the Fiji talking about how they've got these very high-speed disconnects now with the VMs. Does the ARM SKUs have access to all of that? Is that still hold good, or the appropriate drivers or whatever built into that into those VMs to access those high performance disks?
Yes. So one of the improvements we're making for all general purpose virtual machine families in the latest generation, the V6 generation, is allowing NVMe local storage disks for our customers to attach. In the past, it would be a SCSI disk. And so with NVMe, we can give up to a 4x improvement in IOPS, so a huge performance boost there. And we're giving this on ARM as well. So customers won't have to do anything special for ARM. That's been our priority and one of our key results in delivering ARM since the onset of us delivering ARM in Azure, is to ensure that customers are going to see functional parity as well as feature parity. So features like NVMe, features like Premium V2 or accelerated networking, or Azure Boost, which I think you had the Azure Boost folks on recently.
That's what I was referring to, Azure Boost and Project Sirius as well.
Yes.
To see. So all of those would work with the Cobalt processor VMs.
Yes, indeed.
That's awesome.
If this is something you're able to disclose, what other workloads do you see usually working around this series of VMs or the customer mix of things? What other services do they usually use it with?
So right now, the only higher level service that you could run in an ARM VM would be Azure Kubernetes Service. Customers could run a self-managed open source database or a self-managed Kafka solution, or really any open source tech stack solution. But in terms of the Azure services, AKS is the one that we're seeing the most of. And you talked about other features or services like Azure Functions earlier, Azure App Service, Azure Database for Postgres. So right now, customers can't run those on an ARM VM. That's something that our customers are asking for, and it's something that we're investigating internally. Don't have anything to share on that in this podcast, but we're really seeing a lot of adoption with Azure Kubernetes Service, and it makes sense because, again, ARM VMs are really optimized for cloud native workloads, right? And then that compounded with the fact that the porting effort of moving a containerized workload to ARM versus a full in the box virtual machine workload is much, much lower. So a containerized workload is really fairly easy to move to ARM. It may be as simple as just finding an ARM build of the container that you need to use, and you are kind of plug and play. So we're seeing a significant adoption and kind of synergy with AKS scenarios, Cynthia.
And specifically with the Cobalt processor kind of version that you're releasing now, is there any consideration in terms? That's just a regular ARM processor, right? There's no nothing special about the Cobalt in terms of architecture that customers have to worry about, right? If they were on ARM before, on the ARM V1, this is just V2. They just, as you said, do the scale up, scale down thing and kind of migrate over. There was no other consideration in terms of drivers or libraries or anything they need to be worried about, right? That they're already using. Those would all continue to work with the Cobalt 100.
Yep. One of the key deciding factors in delivering the Cobalt 100 was ensuring that our customers weren't going to have to change anything to use it. So customer can run the same workload that they ran on the V5 or prior generation ARM VMs on the Azure Cobalt 100 with zero changes. Now, the architecture generation is later. So if we want to nerd out for a second, the prior generation was based on a Neoverse N1 ARM core, and the Cobalt 100 is based on a Neoverse N2 or an ARM v8 versus ARM v9. And so what that means is customers could recompile their code for ARM v9 to perhaps get some performance enhancements if they do compile their code, something like a C or a C++ or a Golang workload. They could recompile to get more performance or more features that the new processor feature set offers, something like SVE2, for example, which allows more kind of customizations and vectorization capabilities. So you could recompile to get more benefits, but you don't have to. And you're still going to get great performance without changing anything.
I'm guessing at some point, all of the third-party products and libraries will also get rebuilt and recompiled with this. Is that an expectation? This new architecture of ARM?
Yeah, and again, they don't necessarily have to, right?
Correct.
So maybe a vector database where they would see improvements by being able to kind of optimize their vector instructions using ARM. They might recompile. But again, customers really don't have to.
Yes, Arpita?
Yeah, I hope you can hear me now. The other thing is that for the Neoverse architecture, like N2 architecture, it basically optimizes for performance per watt and performance per dollar, as a result of which, the customers can benefit and leading to, lower price for them. So that's the good part. And as we are as a whole moving towards more eco-friendly infrastructure, environment-friendly ones, lower power, being power efficient is always going to be helping. So that's a plus point from the N2 architecture perspective.
And can we talk about, percentage-wise, like how much more cost-effective it's going to be? Like, is there sort of a target range that we have, or is it going to be based on workload?
So we have not publicized pricing right now. We should.
Ah.
I can't believe we haven't said this already, but the preview is free for these VMs right now. Okay, so we really urge anyone who's listening to this podcast who's interested in trying out ARM, you have a perfect opportunity to come in and use the new Azure Cobalt 100s for free. That won't be for long, right? Because we're going to start charging once we enter general availability. But in terms of the cost effectiveness or price performance benefit customers might see, we have not publicized pricing yet. That will come soon. We do know that customers will get a 40% improvement in performance, or up to 50% for Java and up to 100% for something like a .NET if you're using .NET 8 with all of its performance enhancements for ARM. So we're really offering, kind of levels of magnitude performance improvement compared to the prior generation of ARM. And while we haven't publicized pricing, customers should expect a significant price performance benefit with the latest generation.
Awesome.
That was an awesome answer. No, earlier you mentioned that ARM processors are really good for cloud native workloads. Why is that? Is that more of a design difference, or what makes it so?
Yeah, it's kind of twofold. What Arpita touched on earlier, and Arpita, I'm not sure if we could get your camera back on. Maybe you're still having network difficulties there, but
I'll try.
So kind of with our systems level approach, ARM offers the unique value of allowing us to build our own platform, right? And we see cloud native workloads as kind of the workloads of the future. They're really of the now, but they're continuing to grow. We expect most customers to be running these types of modern workloads within the next 5 to 10 years, right? And with ARM, we're really able to take control of the end-to-end design, and we're optimizing specifically for cloud native workloads, right? And that goes down to the physical core, one physical core per vCPU, specific performance optimizations. We're able to explore introducing specific accelerators that would help specific cloud native workloads. But it really comes down to the performance consistency at scale and then the linear performance scaling at scale that a physical core per vCPU, as well as the ARM architecture intrinsically offers for things like these cloud native workloads. And then on the flip side, from the customer's perspective, cloud native workloads are really going to be the easiest to move to ARM. So if someone's running a Java 20 in containers on AKS, they're running basically the latest and greatest technologies that offer the greatest performance that these open source communities are offering. And all of that is going to run on ARM without them having to change anything, right? If a customer is trying to take something like .NET 5 or .NET 4, or they have this legacy workload that they're kind of maintaining, and maybe have a lot of technical debt, that's really not a good fit for ARM, right? So cloud native modern workloads are going to be the easiest to move.
And just to add to that, as the customers are trying to modernize their workloads, they are also trying to see how they can leverage the multi-cloud approach at this point. I mean, have their workloads on multiple clouds and transition from one cloud easily to another cloud without much overhead, without much resources, and learning curves. So that is also something the cloud native workloads would obviously support, and easy to migrate help customers in that way.
Cool. This has been really good, very insightful. Thank you so much for sharing this. Cynthia, is there any more questions you think you have for Arpita and Noah? Okay, I think we've really exhausted all the questions that came to our minds. Anyway, so if there's any kind of links or resources that you can share with our listeners, please send them over to me, and we'll put them along with the recording. But I want to thank both of you for taking the time today to come on and educate us on the benefits of ARM and what this new Cobalt 100 processor brings to our Azure customers. It sounds very compelling.
Thank you.
Yep. Happy to be here. Thanks for having us on.
Thanks a lot. Take care.